Hello, everyone. This is Kaizen Base. Today we will learn about the difference between fixed quantity conveyance and fixed time conveyance and the effective condition of post-process pull system.
Post-process pull system is one of the important factors in just-in-time production. This time, we will learn about the principles of conveyance and the conditions for the successful production of post-process pull system.
So, let's get started with the lecture. Mr. Kai, good morning. Do you have time now?
Not really, I am working on the materials for tomorrow.
What is the difference in the usage of fixed quantity conveyance and fixed time conveyance? I know the difference between fixed quantity conveyance and fixed time conveyance, but I am not sure how to use them properly.
You mean fixed quantity conveyance and fixed time conveyance? The difference between fixed quantity conveyance and fixed time conveyance is also an important point in just-in-time. Well, shall we learn a bit more about it?
Yes, I would love to right now.
There are basically two ways of conveyance. One is the fixed quantity unfixed time conveyance. The fixed quantity conveyance you mentioned just now is exactly fixed quantity unfixed time conveyance. Fixed quantity unfixed time conveyance refers to the way to irregularly convey a fixed amount each time. For example, a fixed quantity of 100 parts will be conveyed each time instruction is given. The time when parts are needed depends on the timing when Kanban is removed. The other one is fixed time unfixed quantity conveyance. The fixed time conveyance you mentioned just now is fixed time unfixed quantity conveyance. Fixed time unfixed quantity conveyance refers to the way to convey the required amount at a fixed time each time. For example, the required quantity of parts based on the given instruction will be conveyed every 2 hours. The required quantity is determined by the number of Kanban.
So the fixed quantity conveyance means to convey the fixed quantity when needed, and the fixed time conveyance means to convey the required quantity in the fixed time.
That's right. Now I will explain the criteria for choosing fixed quantity conveyance or fixed time conveyance. Keep in mind that, in principle, the fixed quantity conveyance is adopted in the factory. When the parts used in the post-process reach a certain amount, a Kanban will be issued and the parts should be withdrawn. It is a so-called post-process pull system. On the other hand, if the pre-process is performed in a remote area, such as a supplier, fixed time conveyance should be adopted in principle. The parts are conveyed at a predetermined time, and the supply quantity is not fixed depending on the production number in the post-process.
Why is fixed time conveyance basically adopted for remote area?
If the parts have to be conveyed from remote area, it will take time to arrive and will be surely essential to make an early start. So even if instruction of conveyance is given when the required quantity is known, it will not be in time for use. Therefore, it is essential to predict the required quantity in advance and have the parts shipped at a fixed time in order to avoid a shortage of products.
But if predicted too much in advance, will there be a large number of inventory?
Yes, it will. If the quantity brought over are more than needed this time, adjustments such as reducing the number next time should be made to control the inventory so that it does not increase too much. Therefore, the quantity brought over each time is unfixed quantity. This is the principle of conveyance, but it is highly recommended to make a choice based on the characteristics and management level of the company and factory. Especially in the factory, it is required to gradually raise the level of logistics management and finally aim for fixed quantity conveyance.
I see. Fixed quantity conveyance is exactly the idea of post-process pull system. By the way, I've heard that many factories aren't doing well when it comes to post-process pull system. Is there any good way to make it perform well?
Oh, that's a good question. Now, I will explain about it. As an example, let's assume that the machine parts are the products to be supplied to the assembling process in the post-process. And suppose the scheduled production quantity for this product is thus planned at a fixed number each day. It is ideal that the assembling process of post-process is actually progressing based on the production planning line in this way. In this case, As long as the scheduled number of machining processes of the pre-process is properly completed, the post-process pull system will function well. On the other hand, what will happen if the assembling process of the post-process performs the production in which the delay and recovery repeat in this way?
When performing the post-process pull system production, do not make things that are not required by post-process now. Therefore, the production will have to be stopped when a certain amount of inventory is stored in the pre-process.
That's right. The part of this arrow is the timing when production must be stopped. In the machining process of the pre-process, production is stopped when the inventory of the pre-process reaches a certain amount. However, after that, at the timing when the post-process has to catch up the production, the withdrawal will be more than the capacity, which will result in measures such as working overtime and at the weekend have to be taken to deal with the situation. After that, there will be a delay in the assembling process again, which will cause the machining process to stop production as well. Then, the assembling process will have to catch up with the production again at the end of the month. In that case, in the machining process, the operators will have to work overtime to deal with the situation again, but still in the worst case, there will be a shortage of products due to the fact that overtime hours have already run out. In this way, if the production has to be caught up due to the delay in post-process, the post-process pull system production cannot be realized. Even if it can be realized, the waste will be increased and the cost will get higher.
I see. If such unstable conditions occur frequently and the pre-process continues to be blamed for the shortage of products, it seems that the exact opposite of the ideal situation will happen. In order to protect its own workplace, the pre-process tends to have a large number of inventory to deal with the large fluctuations in the post-process. In this way, we don't know at all what the post-process pull system production is exactly for.
That's right. That's exactly what happens in the factories where post-process pull system isn't working well. By the way, which of the following do you think is the problem in this case? 1. Post-process pull system does not match this factory. 2. The pre-process does not have the ability to keep up with changes in the post-process. 3. There is a large fluctuation in the number of production in the assembling process of the post-process.
Is it 1?
Unfortunately, it's not. The correct answer is 3. In fact, there are many cases in which companies that have tried the post-process pull system production and gave up on the way assuming that 1 and 2 were the reasons, and crushed the possibility. It is very pitiful that the possibility is crushed straight away even though it is actually possible to perform the post-process pull system production. Unless the problem of the large fluctuation in production in the assembling process of the post-process of 3 can be solved, the post-process pull system production cannot be realized. In other words, the point is to improve the Heijunka level of the post-process. By steadily raising the level of post-process pull system production, it is possible to notice immediately where the abnormality is in the entire flow of production. If measures are taken steadily against the discovered abnormalities, the waste will be reduced gradually and costs will decrease. It is no exaggeration to say that whether this point can be understood should be a turning point in the success of the implementation of Toyota production system.
I see. That is to say, the aim is to achieve the state of continued Heijunka production without delays and over progressive production. Now I understand that it is essential to carry out the Heijunka plan every day in order to realize the post-process pull system production.
That's right. And in order to achieve the production plan with reliability every day, it is essential to thoroughly take steady measures such as standardized work, Heijunka, operation of Kanban and 5S. The steady measures taken right now will surely lead to great results in the future.
Mr. Kai, I think there is one more important thing.
Oh? What's that?
Enthusiasm and teamwork. Even though steady measures are taken, there are inevitably times when we want to give up on the way. In order to overcome such a situation, it must be necessary for each person to have enthusiasm and teamwork spirits.
Absolutely right. Maybe it is the most important point of view. Oh, by the way, Mio, we have mentioned the word Kanban just now. Let's learn about the role of Kanban in detail tomorrow.
I see. I will be looking forward to it. Now, we make a summary of today's lecture. The two basic methods of conveyance are fixed quantity conveyance and fixed time conveyance. The basic distinction between the two terms is that fixed quantity conveyance is basically adopted in the factory, and fixed time conveyance is basically adopted by the suppliers in the remote area. The primary reason why the post-process pull system production does not go well is that the production number of post-process, especially the final process, fluctuates greatly. If Heijunka has not been performed in the post-process, the pre-process will have to follow the fluctuation, and the fluctuation becomes larger as tracing back to the upstream process, and cannot be followed if it is too large. Therefore, in order to realize the post-process pull system production, it is essential to have the ability to make a plan for leveling the post-process, and the manufacturing ability is required to carry out the plan smoothly. That's all about today's lecture. So, see you at the next theme.